Okay, a very good evening to everyone who is on this online session. Welcome to the interaction session in which I will take up your queries and your doubts. I have already received some queries through the teaching assistants via email. So maybe what I will do is I'll first take those queries and then I will take down the queries which are going to be put up by you on the YouTube channel. So the first question which has been asked, there are two questions actually by Mr. Praveen Kumar. What is the design load factor of Voyager aircraft? So Voyager is a very special aircraft. It was designed with a very specific mission that we should be able to go around the world non-stop. And such aircraft have design considerations quite different from those of standard aircraft. So I am not actually very much aware of the exact design load factor of the Voyager aircraft, but I can surely tell you that it is not as high as 2.5 or 4, etc., which is there for other aircraft. Okay, so as I mentioned, in some aircraft where you can convince the regulatory bodies that it's a special aircraft for some special requirements, you can get a concession on the maximum load factor values. Okay, so it need not be always the same value as that is there for other standard aircraft. The second question by Praveen Kumar is, what is exactly a pull-up maneuver? Pull-up maneuver basically is when the aircraft goes into a dive. After dive, when you bottom on the dive and come on the top again, that is called as a pull-up maneuver. So if I just show it to you by the action of my hand, there is an aircraft that goes into a dive, and this particular thing is called as a dive pull-out. When you dive and then you pull out of the dive, that is called as a pull-out maneuver or a dive pull-up maneuver. Ajit has a question. I want to build a simple flight simulator by taking into account power available, fuel remaining, and atmospheric conditions for computing acceleration, climb rate, G-turns, etc., using aircraft specifications available online. Please suggest how to go about this or any good material. It's not very easy, Ajit, to be able to do this, but I don't have direct information or any specific knowledge in the area of flight simulators. So I really can't answer this question for you. But my suggestion to you will be that there are many communities available online on flight simulators where you can put your doubts and your questions, and they will be able to answer. And plus, try to contact some students in the past who have built flight simulators who will be able to help you out. Okay. Praveen Kumar again wants to know, please state the factors which maximize endurance of a propeller-driven plane. For a propeller-driven plane, I think the endurance formula is simply 1 by C L by D log of weight ratio. So the factors that affect the endurance of propeller-driven planes would simply be the SFC, which should be as low as possible because it is in the denominator, L by D, which should be as high as possible, and log of weight ratio basically means weight log of the weight of the aircraft during the before the endurance mission starts upon the total weight. So the lighter you make the aircraft, the better it is. So these are the three things: lightweight, lower empty weight, higher L by D, and lower SFC, that will directly affect the endurance of a propeller-driven plane. Why do VTOL aircraft have very less fuel efficiency, even though they direct their energy to lift themselves efficiently? A question by Vimal Kumar. No, I don't agree that they are doing it efficiently because they are using thrust to overcome the weight. So that means they need to have a thrust to weight ratio more than 1 because they take off vertically. And the moment you have thrust to weight ratio more than 1, you have extremely high fuel consumption, and therefore they are not very efficient. During cruise, when they transition to cruise, they may require much lower power, but the engine is heavy to overcome the vertical takeoff and also the vertical landing requirements. Prakash R has a question: how to compute power available for different aircraft? Does it depend on any other factor other than engine efficiency? No, Prakash. Power available depends only on the power plant characteristics. It doesn't really depend upon the aircraft characteristics. So power available is purely from the engines. Okay, so aircraft parameters don't come into play. Power required, of course, is affected by the aircraft aerodynamics and the weight, etc. Shubhang Charantimath has a question. What is the difference between atmosphere vehicles and space vehicles? Atmospheric vehicles are going to encounter drag, and they are going to also create lift because of the relative motion between them and the atmosphere. Whereas space vehicles are going to work in an environment which is very cold, and also they are also going to work in environment which is very sparse. So they can be of any non-aerodynamic shape. Look at satellites, look at the International Space Station. There is absolutely no consideration for aerodynamics or shape optimization there because there is no lift or drag on those vehicles. What is practically meant by downwash and induced drag, and how can it be visualized? Please do explain more profoundly, by Kshitij Gupta. Okay, Kshitij, what I will do is I will try to share, if possible, I'll try to share, if possible, one video that can help you to understand that can help you to understand the concept of the concept of induced drag. Okay, so I'll just try to go straight away to that particular slide. Okay, so I would like to now show you a small video where I'm going to share my entire screen. So just give me 1 minute. Okay, so I'm going to show you a small video which will help you understand the concept of induced drag first. Okay, I'll try to explain to you the concept of induced drag. Okay, so have a look at this video. I will show it to you once again, but before that, I'll give you some very brief background of what you're going to see. So what you just now saw is, basically a sheet of, a sheet of this particular cloudy gas is being created. Because air is not visible, therefore we don't get to see what happens to the air as the aircraft goes past it. So a sheet of cloud is being created, okay, and then a model of aircraft is being made to pass through this sheet. And when the model of the aircraft passes through the sheet, you can look at the wing tips. At both the wing tips, the air actually starts curling inwards. And when you couple that with the forward velocity, it starts going into rotation. And the energy of the free stream, a lot of it is consumed in creating those round vortices. And that could be considered as a loss of energy. And hence, one could take it equivalent to as a kind of a drag which tries to resist the motion. So I'll show it to you once again. This is a very interesting video that shows the formation of the wing tip vortices. So we notice this. Now this is one example of how induced drag gets created because we are actually pushing the air down. Okay, so when we push the air down, then that causes this particular vortex to be curling at the wingtips, and that represents the induced drag. So this is how we can visualize induced drag. Now, as regards downwash is concerned, uh, if you look at the flow over any aerofoil, now I have to search for it if I can find, but I think in the course I have shown you several videos where I show you um, you know I show you the flow of the air behind the aerofoil. Let me see if I can locate once again some such video, and then I will be able to probably show you once again what I am trying to highlight. So if I don't know whether I can quickly find it. Okay, perhaps I have to go into basic aerospace. No. I'm just trying to find some videos which talk about flow behind the aerofoil. Probably I'll take some more time to do it. Probably it should be in lift generation. Or in airfoils. Let me see if this video will give you some idea. Okay, not very clear, but still I can try to show you some example, or perhaps we should be able to look at it let's see if we can get some idea. Meanwhile, I would request other people to keep their questions coming, because questions are very important. That will allow us to. Okay, so I just located one small I just located a video online which I'm sure you are able to see, or I should say, I hope you're able to see. Okay, so you can see so as the flow goes over the aerofoil, it is actually turned down. You can see it is turned down. This turning down of flow is basically the reason why lift is created, because when some force is pushing the air down, then obviously there will be a reaction and the air will be pushing the vehicle up. This particular curling of the flow behind an aerofoil, when it creates lift is called as downwash, and the downwash is very important to create the lift force. All right. So I have already finished the questions which were asked by the students in the email. Now I'm just looking at the questions which are available on the YouTube. So Archit Chatterjee has a question. What is the real meaning of stealth? Is any aircraft have achieved proper stealth yet? If so, then how? Rafael was able to lock 5th-generation aircraft in an exercise. Now that locking is a different issue. Locking and unlocking of an aircraft is a function of the missile technology, radar technology. Stealth basically means the ability to hide yourself from the enemy, either from radar or from sound or from looks. So there is visual stealth, there is visual stealth, there is radio or radar stealth or radar signature, oral signature, and visual signature. So that's all. So if you make the aircraft not so much visible to the enemy by any means, you are increasing the stealth, whether thermal signature, whether oral signature, whether visual signature, or whether radar signature. Vimal Kumar Bharati has a question. How much impact will biomimetics have in airplane design in the future? Why in the future? Even now also, there are certain features in an aircraft which are inspired by biomimetics. Okay. Why do some airplanes like B787 have blended wing tips? Blended wing tips essentially because those are going to give lesser interference drag. Wing tips, are going to give you lower induced drag, but if you blend them very beautifully with the wing, they give you lower induced drag and also they help in reducing the interference drag. That's how it works. Right. So I don't see any more questions on the YouTube chat. So I will wait till questions come up. Okay, Prashant SS, example of forward swept wing and its advantages and disadvantages. In a forward swept wing, the example is X-25, an experimental aircraft made by the American Defense, Northrop Grumman. I think they made X-25, and then there is also an equivalent example in the Russian sector. So in one of my NPTEL courses on aircraft design, I actually talk about it in detail, but and that course also, by the way, is currently going on. But doesn't matter. I'll quickly locate one slide from that course on aircraft design where I discussed about this stealth issues. Okay, and there I will try to show you. Okay, so I'll go to my presentation on aircraft configuration design, where I'm sure there is a picture about stealth. Yeah, so all right, so I'll once again share my screen. And I think you can see this this image, which talks about stealth. So two aircraft, Sukhoi 47 from the Russian stable, shown in the bottom of the screen in black color, and X-29 from the Western stable. Both of them have forward swept wings. Okay. So now let us see the benefits of forward swept wings. So as you can see in the figure of X29, there is a black colored line drawn on the wing. So that line broadly indicates the way in which the airflow takes place over a forward swept wing. The air is gathered from the tips towards the root, as you can as is shown in those lines, and therefore the root portion of the aircraft tends to get more and stronger airflow, and the tip portions of the aircraft tends to get lesser airflow. So what happens is that the uh, tip is the place where the ailerons are located, and if ailerons are in a stalled region of the aircraft, then you lose the lateral control. Okay, so uh, the tendency of an aircraft, a normal delta wing or a normal swept-back wing, is to have the flow from root towards the tip, and that is not desirable. Forward swept wings, they give this particular benefit, but there is a problem. The problem is that they normally so in a forward swept wing, when the lift is increased by, let us say, increase the angle of attack, so then what will happen is that the area which is towards the tips outboard, that will start getting more load. Because of that more load, the leading edge will encounter higher angle of attack. It will deflect in such a way that the alpha increases. So increase in angle of attack leads to increase in lift, and that increase in lift again leads to increase in angle of attack. This whole thing leads to a lot of torsion, and then ultimately the torsion is so much that it's called as torsional divergence, and it can tear the wing at the root because of the massive amount of torsion. This is the biggest drawback of a swept forward wing. In a swept back wing, what happens is that the increase in the lift actually does not the increase in the lift actually twists the wing in such a way that the nose comes down, and that helps us in not reaching the stall or not increasing it further. So it doesn't couple. In case of swept forward wing, there is a adverse coupling, and that leads to torsional divergence. Now this torsional divergence can be handled by what is called as aeroelastic tailoring. Okay, that is by designing the aircraft in such a way that the aircraft is strengthened in a manner that the loads which are coming are taken care in the right direction. So I suggest that you enroll next time whenever the aircraft design course runs online. You will get the answer to these questions. A logical follow-up of the course on Introduction to Flight is the course on aircraft design. Okay. Arhat Shah, which softwares can be used to simulate the wind tunnel test on different aerofoils or wings? So there are several airfoils available. There is one called XFLR5. There is one called Tornado. There are many other softwares that are available. There is something called as airfoil tools, which is also sufficient for analyzing airfoils. But if you want to analyze wings, then you have to go to slightly better softwares. Okay, Harry Singh, why would aircraft having canards have shorter fuselages? This is not something that is a plan. This is what automatically happens because because the aircraft which have canards, they have the tail front. Okay, so they tend to have a larger moment arm compared to the ones where you have a tail on the back. You have to make it longer because you have to have sufficient moment arm between the tail surface and the aircraft center of gravity. So because rear part of the fuselage is actually mainly required to put the tail far behind so that it can have a larger moment arm without the need for very large area. Okay, so therefore, if you don't have a requirement for a very long fuselage just to keep the tail away because you are already able to put it in the front of the fuselage, then the aircraft fuselage becomes shorter. Okay, so Prashant says thank you, and I will surely enroll, and thank you for explanation. Great. Vaishempai and Productions. What is the leading edge droop and how does it help in high angle of attack performance? Leading edge droop basically means that the nose of the aerofoil, the front of the aerofoil, can be given a slight droop. So it gives you larger camber. When you give a larger camber, then you get much better performance at high angle of attack, because at high angle of attack, if the nose is drooped, you will actually effectively lower its lower. Otherwise, the air will have a very large area to climb. But if the leading edge is drooped, then you give a rounded area for it to climb. So you avoid the separation and stall at high angle of attacks. What is a mark tuck? Okay, mark tuck is a phenomena in delta wings where there is a sudden loss, and it leads to I would say moment. It's an aerodynamic effect when the nose of the aircraft tends to pitch downward as the airflow around the wing reaches supersonic speeds. Okay, so suddenly it starts tucking. It just gets a downward jerk. That is called as a mark tuck. Which areas have the potential for the research in aerospace engineering? Every area. Aerospace engineering, all the areas that you can think of. You name any area, and always someone can find some new and interesting and modern research area which can be taken up. So it's very difficult to answer. All areas have the potential for research in aerospace engineering. It's up to you to take up the research in that area. All right, let's go ahead. Any other question anybody would like to ask? Oh, a lot of questions have come now. Okay, Vignesh TRZ. Sir, when does a jet engine knock, and also does the engine performance reduce while raining? Actually speaking, the engine performance actually might increase while raining or improve while raining, because rainwater is basically having higher density than air. So the mass flow in the engine will increase when you actually inject when you have air, rainy water. So actually speaking, it might actually increase to some extent. Okay, but of course, if it is too much, then there can be some issues, right? Then, when does a jet engine knock? A jet engine knocks when there is some instability in the combustion, either because of a surge or a stall in the engine because of mismatch between the compressor and the turbine. Yash Makwana says, I am in first year electrical engineering. Should I enroll in it? Now, when you say it, I don't understand. Are you talking about Yogesh? Can you just clarify what do you mean by it? Are you saying the course in aircraft design? Then I would suggest that if you have done this course on Introduction to Aerospace Engineering, then I think you have sufficient background to do the course in aircraft design. Yeah. Prashant sir, your opinion on skunk works and such institutions here in our country, like the revolutionary planes SR-71, U-2, D-21 drones, F-119, etc. Engineers like Kelly Johnson and Ben Rich. Okay. So are you asking that why don't we have skunk works in India? Well, I would love to have some skunk works in India. I would love our government to. Yeah, so yes, Makwana, yes, you can join aircraft design course if you have done this course and if you are able to score well in this course. So coming back to skunk works, it would be a dream come true for aerospace engineers if the government actually funds, or government or any private company funds and sets up some kind of a research uh, group like Skunk Works in India. Right now, I'm sorry to say we don't have such things, but who knows? Tomorrow there might be a Skunk Work equivalent in India also. I would love to be a part of such an organization. Really, it will be nice. Okay, keep your questions coming. We have already spent around 30 minutes, so half the time is over. We have only half an hour remaining. So if you don't have any specific questions, may I ask you to give me some quick comments, suggestions, and feedback regarding this course? Did you enjoy the course? Are you enjoying the course? Do you like the way in which we are using interns to create content for students? Okay. Archit Chatterjee, what do you mean by fly-by-wire? As it was in news due to MiG-29K and difference between flares and decoy. Okay, let me answer two questions separately. Fly-by-wire basically means a control system in which there is no direct mechanical link between the control stick of the pilot and the control surfaces. No direct mechanical link. So the pilot basically communicates intention to the control system of the aircraft, or I can say the flight controller of the aircraft, using the control stick. Depending on how much pressure the pilot applies and what direction the pilot moves the control stick. Now, this particular pilot input is then first checked by the flight control system based on the conditions in which the aircraft is operating. Is it a safe input or an unsafe input? If it is a safe input, then the control system execute that intention and provides the required amount of force to the control system, either using electrical actuators or hydraulic actuators. But if the control system determines that this particular input is potentially unsafe and can take the aircraft into a dangerous regime, it will modify or tailor down that particular input so that the safety limits of the aircraft, or what is called as a flight envelope of the aircraft, is not exceeded. The safe flight envelope is not exceeded. Okay. Prashant, it would be a dream if we can get opportunity to work for such institution. So your dream can come true, Prashant. So many people are working with me as interns. They approach me for internship, and if I really see, but the thing is that many people write to me for internship. Now I can't give it to everybody because I have limited resources, limited energy, limited time. So I have to first check whether they are really serious or they have just like that given it. So I try to find out by some mechanism whether the person is really serious. And if I find that they are really serious and committed, then yes, I can give you a chance for internship, no problem. But there is a limitation on how many people I can take. Okay. Harsha Chamalapur. Sir, power available depends on any other parameter other than engine efficiency? No, I have already answered this question. It depends only on the power plant characteristics. Power available is a function of how much power the engine is producing. It has nothing to do with the aircraft, actually. Power required is a function of the aircraft parameters. Sarthak Narnor, my NPTEL marks are not updated yet. I really can't do anything about it because I am not administrating the NPTEL marks. So you have to request your NPTEL coordinators for this. Vimal Kumar Bharti, I definitely enjoyed the course since all the theoretical concepts were linked properly with videos, pictures, and a good amount of discussion. I was also introduced to a good amount of applications. Okay, very good. So I'm happy that you enjoyed, but I am looking for very constructive suggestions. I'm looking for comments which can be used by us to improve the course when we offer it next time. Okay, Bharti has already replied about marks not being uploaded, so I don't have to answer it here. Anyway, I can't answer it here. Kshitij Gupta, please give a visualized explanation about downwash and induced drag in profound. So I've already explained you I think, Kshitij, I have taken the trouble of going and locating videos and showing it to you. I don't know whether you were able to see it or not. Sir, rain increases speed because it has higher density than air. No, no, not speed. It is mass flow. Water having a density of 1,000 times more than air, if some water gets inside the engine, the mass flow increases. And that mass flow increase can actually generate more thrust. So it can be beneficial. Of course, nothing can be continuously beneficial. You cannot say we will start. When I was a student, we learned about something called as a water methanol injection to increase the mass flow of the engine in certain situations. So from there, I'm just saying, I'm assuming that it will help us in increasing the mass flow. So yeah, water methanol injection in aircraft, you can look up online. Some fighter aircraft also use water injection for a boost to short burst during dogfights. When the pilot turns the water injection pump, water pressure moves the valve to restrict fuel flow to lean in the mixture and water methanol in the system, and that helps you higher thrust. All right, so let's see. Praveen Rajput, slides embedded in transcript are not clear, they are blur. Okay, this is the point which can be noted. Actually, transcripts are not meant for you to read the slides. Actually, transcripts are meant for you to revise what you have seen. You are supposed to watch the videos, and transcripts are there only if you have a problem with my language or with my, uh, way of speaking. Archit, being an electrical engineer, I have come across this course because I'm inclined towards joining the Indian Air Force. I have learned a lot. Most of my doubts were cleared. Thank you, sir. Thank you, Archit, for your clarification. And I'm glad that an electrical engineer is able to appreciate and understand basic concepts of aerospace engineering. So, good. That is what was meant. That is what was meant to be in this course. This course is meant as an introduction to aerospace engineering for any engineer, or not necessarily only aerospace engineers. Okay, let's go ahead. Yeah, so waiting for your comments, waiting for your questions, waiting for your queries. Okay, Sarthak, the content is updated, but the tutorials are not that much clear, and it was getting tough to solve assignment questions. Also, the videos are a little fast, and some of the contents in slides was incomplete. Okay, so Sarthak, you have to help me by giving me specific examples. Okay, wait, are you in the wrong class, because this is not an interaction for aircraft design. So this is an interaction for aerospace engineering course, Sarthak. If you are here for the aircraft design course, then I think you have to go. You have to wait till about 5:15. Yeah, Sarthak. So we are in the course discussion for introduction to flight, not for aircraft design. When you are teaching from the PPT, it happens many times that the PPT is not shown. Yeah, so unfortunately, the camera can show either me or the PPT. It cannot show both unless it is a live classroom. So we really cannot do much. Vishwamitra, what are the different types of engines used in the aircraft, sir? Vishwamitra, I have one specific lecture on this called as propulsion systems, and I think it's a part of this particular course. So all the engines, starting from piston prop, turboprop, turbojet, turbofan, ramjet, pulse jet, all of them have been discussed. So I am not able to understand. Kshitij Gupta, sir, can you explain one more time here? What about the downwash and about the wingtip vortex or induced drag? Okay. I'll try to explain to you once again. First, about downwash. So, as air flows over an aircraft wing, it has a tendency to be uh, it has a tendency to be given a downward deflection. So if you look at an air particle as it goes over the wing, it comes in straight. As it goes over the aerofoil and below the aerofoil, it actually goes, it has a tendency of going a little bit down. If something like something has pushed the particle down, this particular downward deflection of the particle as it goes over the wing is called as a downwash. So there is a small upwash which happens ahead of the wing, where in subsonic flow the the flow over the wing, actually there is a slight upward motion, and then there is a downward motion. So that is called as a downwash. Okay. Praveen Rajput, please state the factors to maximize the endurance of propeller-driven aircraft's assignment 11. Yeah, so I already mentioned to you. See, if you have a query regarding assignment, there is a discussion forum for that. You raise the query there, the TAs will look into it, they will bring it to my notice, and we are open to change it. But here, our basic understanding is to try and answer the queries. Kshitij Gupta, I have already tried to explain about downwash. Induced drag, I already mentioned, and I repeat once again. As the aircraft flies through air, there is a tendency of the air at the tips to curl inwards in the form of thick, round vortices. These vortices essentially are going to eat up the energy of the flow, and hence they can be taken as an equivalent of a drag force which is pushing the aircraft behind. So there are many ways of explaining it. One is that the rearward deflection of the lift vector, can be considered to be a kind of a drag force called as an induced drag, or most people explain it by looking at the wingtip vortices. So Vignesh is now answering back to my question, but water, along with air, water gets into the combustion chamber while raining, which is against combustion. No, it's not against combustion. The temperature in the combustion chamber is far, far more than 100 degrees. So water will not remain water. Okay, it will not remain water. Chauhan Abhishek Sheshnath, sir, in which research projects you are working? Like, give us an overview. Looking for an intern under you. So Chauhan Abhishek, Abhishek Chauhan, this is not the place for asking for internship or for knowing what I'm working. And I think you should be able to do some homework, and you should be able to look online and check the projects in which I'm working or the papers which I have published. And then only you should write to me for an internship. Vimal Kumar Bharti, I'm very much interested in using biomimetics in airplane design and improving efficiency. How should I approach excellent professors for projects or internship in this field? By writing to them. First of all, you have to find out who are the people who are working in this area. And once you identify those people, you write to them and say that I'm interested in biomimetics applied to aircraft design. Would you be interested to offer me an internship? And then wait for them to respond. If they are interested, just like you are interested to work with the professor, similarly, the professor also must be interested to work with you. It is both ways. It's not just a one way. It's like a one way affair, So it should be both ways. So we should be interested in you, and you should be interested in us. Then relationship can start. So the only way to do that is to first find out who are the people working in this field, and then write to them. So biomimetics in airplane design can be considered to be something related to morphing. So find out which areas, who are the people working in morphing of aircraft in design, and then write to them. Harry Singh is asking on which topics can the final year project be done for mechanical engineering related to aeronautics? Again, it's a very open question. Remember one thing, that aerospace engineering, according to me, is only an application or a specialization of mechanical and electrical engineering. Okay, so therefore a mechanical engineer can do many problems or tasks which an aerospace engineer does, or in aeronautics. So there is no shortage. So there are many applications, and in fact, if you write to a faculty member or a researcher under whom you want to do internship, they will guide you. If you are a good mechanical engineer, you can do good aeronautical engineering work, because aeronautical engineering is basically an application of mechanical engineering. Mechanical is mother of all the branches, according to me, mechanical and electrical. So therefore, there should not be any problem. So Praveen Rajput again wants to know, what is the load factor for Voyager aircraft? I was unable to find the answer. My answer is, I don't know. I really don't know. Whenever I know it something, I will let you know. But I don't know right now. I don't have it on my. I don't have it with me as a number. Okay, Vimal Kumar is thanking me. Okay, fine. Thanks a lot. Any other question? Govind Raj has a question. Nano composite materials can be used for fuel efficiency, by which the propulsion mass to thrust ratio can be achieved with high efficiency. Oh, yeah, quite possible. See, when you say nano composite material, I'm not very clear whether it is for structure or for the fuel efficiency. I know that composites can give you much better structure, and therefore it can be a lightweight structure, so that can help you to achieve fuel efficiency. All of the modern aircraft which are very, very lightweight, for example, Solar Impulse, they are all made from high quality composites. Vaishampayan Productions, what causes spin in the aircraft and what can we do to tackle it? Okay. Spin is an undesirable phenomena in the aircraft, which is a coupling between the pitching motion and the yawing motion and the rolling motion. So what happens in a pitch is that, imagine there is an aircraft which is flying, and slowly it goes into a increase in the angle of attack and hits the stalling angle. Now, when an aircraft stalls, it is not necessary that both the wings will fall at the same time, because there is always some imbalance between the two of them. So in general, what happens is, when the aircraft stalls, one wing falls first. Now, as one wing falls down first, there is going to be a loss in the lift. Okay. And then there is a coupling motion between the yawing and the pitching. So the aircraft goes into a pitch, and it goes into a yaw, and it goes into a ever tightening spiral. So it starts with going in this way. So it will be oscillating in pitch, and it will be going into a slowly reducing spiral. This phenomena is called as a pitch, as a spin. So now what happens is that the biggest mistake that people put is, because you are losing altitude, they will put the elevator. But the elevator is going to, so the elevator is going to basically create larger wake on the rudder. So the best thing to do when you have a spin is, first thing is full opposite rudder. So if you are spinning in this fashion, you put the opposite rudder to correct the yaw. Okay. So full opposite rudder, so that you can correct the tendency of going into a yaw. Then you can go into a dive, okay, to increase your speed, so that you can lower the nose and come up with the come against the stalling, and then you go for a dive pull out. So full opposite rudder, going into a dive, and then putting elevator to go for a dive pull out. This is how generally an aircraft is recovered from a spin. Now, with careful design, by giving sufficiently large amount of rudder, by ensuring that under all deflection of elevator, the rudder is not completely blanketed by the wake of the elevator, by designing the fuselage of the rear portion carefully, by doing all these things, you can actually make an aircraft spin proof. For example, there are many aircraft which are spin proof, like canard. One of the good ways of making an aircraft spin proof is to probably I use the power of canards. Okay. Uh, okay. Um, all right. Uh, Abhishek Chauhan, we are able to reduce the weight of our aircraft by using some flying wing models. What are its benefits? Flying wing is not only to reduce the weight, it reduces the weight definitely, but not just that. Flying wing is also meant for aerodynamic and structural efficiency. Again, I would request Abhishek Chauhan to join the course on aircraft design where this particular topic is explained. Govind Raj, and use central thrust to maintain the craft altitude. Okay, I don't understand. What is uh, what is this? I'm not able to relate it. Can we use central thrust to maintain the aircraft altitude? Mm. Can you reword your question, please? Type your question once again. Not able to understand what exactly you are asking. So, Govindra, don't ask questions in pieces like this. Type your question completely in one sentence so that I can understand what you are saying. You are giving me bits and pieces, I'm not able to put them together. Thrust output, which can maintain the center of mass. Yeah, so normally engines are mounted always near the center of gravity for the same reason. During spin. So, are you saying that you will change the engine location during spin? No, I can't understand what you are asking. So, let's go ahead. Some other question anybody has? Okay. Uh, there is a question from Sagar Kamble from what would a pilot of a military aircraft do when the engine of some single engine aircraft like MiG-21 fails after V1? Just do crash landing. You can't do anything. Unfortunately, you can't do anything. You have to go for a crash landing. Okay. Um, how discharge wicks are working used in aircraft? You're talking probably about the static electricity discharge wicks mounted at the tail of the aircraft, right? Probably that is what you are talking about. Nitish Gupta says coefficient of lift can ever be depending on change in span dimension and chord length because it's a dimensionless quantity. Coefficient of lift is basically just a ratio between lift produced upon half rho v square s. That's all. So it is just a way to find out per unit area per for a given speed what is the kind of lift produced by a wing. So it's a ratio. Vishwamitra, can you specify a good textbook for aerospace engineering? The best book to start is Introduction to Flight by J.D. Anderson. That's a very nicely written book, and newer editions are coming out. That is what most people use to start off. Can you explain the aerodynamics of Rafale as it can board different mounts? I don't understand. How does aerodynamics affect mount can be used as fuel recharge to maintain higher, longer flight duration? What do you mean by mount? Are you talking about drop tanks? Drop tanks are there in so many aircraft. MiG-21 has drop tank. MiG-27 has drop tanks. All military aircraft have drop tanks. So is that what you're talking about? So many aircraft have drop tanks. I don't understand the meaning of mounts. You have to use your words very carefully. Does incompressible flow can lead to rotational flow? Okay. So first of all, you have to understand the meaning of incompressible flow and the meaning of. I think this question is already answered in the second lecture of this course. I think you have to watch it very carefully, and there you should be able to get your answer. Okay. So payload. Rafale can take different payloads. Yeah, there are so many aircraft that can take so many payloads. I mean, MiG-27 has 7 hard points. So it can also take different types of payloads. It can take rockets, it can take bombs, it can take missiles, it can take pods, it can take TV guided missiles. So, I mean, there are so many, there's nothing special. There's nothing special in Rafale as far as that is concerned. Okay. So I don't see any specific queries. Okay, I think I have reached the end, almost the end of today's session. Vimana designs, how is it compatible with Elon Musk's rechargeable rockets? Does this indicate new paradigm in cross-planetary transport? Yes, if Elon Musk is able to safely create relaunchable rockets, obviously it will be a new paradigm in not cross-planetary, at least outer space transportation. About Vimana designs, I am not able to comment much because there is a lot of doubt regarding the authenticity and the technical correctness of all those things. So I would not get into that direction. Vaisham Payan, sir, do you think that there is something secret behind the development of USAF B2? If it is not, then why don't we see anywhere else in India? Secret behind development of B2 is the stealth bomber. That's the only secret. They did not want people to know how they are bringing in stealth, because it was the first massive effort to create an aircraft which can be operated with stealth. Okay. Vimana Shasta is the fundamental of Indian temple construction. Okay, I don't know. I'm very poor with temple construction knowledge. I'm an aerospace engineer. I really don't know about temple construction. Is the spark plug used continuously throughout the engine operation or when starting alone? Actually, spark plug is used to give the initial spark. And after that, when it is sustainable, self-sustained, you don't need to give a spark again and again. Do fighter aircraft use GPS or any other system? Well, they can use GPS, but for what purpose? For traveling, for finding their path, yes. But GPS cannot be GPS is still not cleared in aviation as the sole and the fundamental means of navigation. It can be a secondary navigation system, but not the primary navigation system. Uh, Primary navigation system generally is the inertial navigation, INS. Govindraj, maybe those were just blueprints, 3D models for reference. I don't know. See, Govindraj, how can we comment on something about which we don't know? Okay, I think it's time up now. It's already 1 minute past 5 o'clock. So I would like to thank everyone who is there in this particular interaction session. Thanks for your very lively questions. And there is a question about how these aircraft navigate. So they have their own air traffic control, the military air traffic control, and also they use what is called as an inertial navigation system, about which you can read and study when you do any course on navigation. Okay. All right. So I think with that, I would like to say goodbye because I have to take one more session after 15 minutes, and it can become very tiring for me. So thank you so much for being present today. And I will take your leave now. And I wish you all the best for those of you who are appearing the examination. In case you have further doubts, you are welcome to send a message in the discussion forum and we will take it from there. Thank you so much.